Hello, everyone. Hello, Copenhagen, I believe is the thing you should say, right? Hello, Copenhagen. My name's Connell. You hear me all right now? I'm here to talk to you about this. So migrating a feature from the monolith over to a shiny new microservice, or just any size service, but let's call them microservices. So a little caveats to get out of the way, little disclaimers. So this is our team's story of how we did, that. Migrated to from a monolith to a new service, but it's by no means meant to be a comprehensive guide to cover all possible cases that you'll come across if you were trying to do a similar sort of thing. But hopefully in there's some things you might come across and some experiences we can share and learn. So, disclaimers out the way. Let's begin. When we think of a monolith, or when you're thinking of a monolith, you might think of something that looks a bit like this. And actually, this is a simple down version of it. I'm imagining hundreds of boxes and arrows flying all over each other and crisscrossing, and it's a big ball of mud. And in a big ball of mud, it's really difficult to work out where are the boundaries, where are the things, what could I possibly move into a new service? Maybe this bit, maybe we can link these three things together. Maybe that's decoupled enough that we can pull out, or maybe actually the stuff in the green box there is more coupled and more closely related to the stuff in the purple box than it is to the stuff in the red or the turquoisey, cyan, whatever that color is box. So we need some candidates. We need some ideas. What could we possibly pull out? And hopefully if you're doing a similar sort of journey, you're trying to do similar sort of things, try and think of your candidates. What might you pull out? And a candidate could be part of your existing architecture. You imagine something like this. It could be a couple of class libraries in a solution, or maybe you can think about it from a user journey point of view, and maybe it's, if you've got a tab navigation, it's one of the tabs. Maybe it's a specific flow, like a sign-up flow or something. So you've got some candidates. And we ended up picking this bit. This bit, spoilers, is the one we chose. We tried a few different candidates, but we ended up with this one, which I'm sure you can tell is our messaging system. I don't mean like a technical events, messages, commands, all those sorts of things. I mean one of these, like a chat, like you can message people on the other side of the internet. Somebody says one thing, they receive the message, and you can reply. So we tried a few candidates, but this is the one we landed on. Oh, so a little bit of context I should have given. So I work at Stack Overflow. I'm hoping some of you might be familiar with the website Stack Overflow. Yeah, maybe a couple of you. But you might not be familiar with our messaging system. So specifically, it's moderator messaging. So the moderators on the site, they can message the users, and just like any other messaging system, you get a little notification in the corner. You can click it. You get a UI that looks a little bit like this. So moderator messaging, all built within Stack Overflow. And that's the system we ended up moving across, or attempting. That's our candidate that we landed on. But why? Why did we end up with this? Why not all these other things? How do we know that this is the right boundary or a good candidate? So we went for a few things, and I'm going to tell you, again, with the disclaimers, these are the ones that worked for us. There will be other things, but perhaps they work for you as well. Firstly, let's get this one out of the way, because you kind of knew this one was coming. Domain-driven design. If you don't know anything about domain-driven design, DDD is shortened to. Fundamentally, it is that your design, your software design, your architecture, in our case, the services, the microservices that we're going to be designing, should be driven by the domains, so the problem domains, the business problems, and the shape of that. So the shape of the problem you're trying to solve should drive the design of your architecture. It's fundamentally domain-driven design. And there's all sorts of, there's talks you can find on the internet, there's all sorts of literature, loads of books you can read. I'm not going to go too detailed into all of that. There are ways to find the shapes of your business problems. You can go through processes like event storming, you can do domain storytelling, there's context mapping, all these things to try and work it out. None of that was particularly helpful for us with messaging, but the one thing, one bullet point on domain-driven design I wanted to pull out is the idea of a generic subdomain. This is a generic subdomain. There were, I can't remember which book it was, but a book brought out some types. It may have even been the original blue Eric Evans book. The types of subdomains. So you have your core domain, the one that gives you a competitive advantage, the one that if you do this bit of your software well, you will beat your competitors. And then there are supporting subdomains, which are things that are still quite specific to your business, but outside of that competitive advantage. An example for us would be like the election system. It's quite specific to electing a moderator, but if we have the best election system in the world, it's not really going to give us a competitive advantage. And then there's generic subdomains. These are ones that everybody could have. And an example I like to give of a generic subdomain is authentication. We've got authentication, some kind of login, something like that. You've probably got some kind of authentication, a login flow, sign-up flow, something like that. And I've worked in quite a few microservice architectures that have had a user's service or an auth service or something along this. So that is an example of a generic domain. And one of the things about generic subdomains is somebody's probably already done it somewhere. Somebody's already made a product that you can go and buy. Instead of having to build your generic subdomain, you can go and often find them because they're generic, because they're common. Authentication, you can think of things like Auth0, if you've heard of them, or Active Directory, Azure Active Directory, or Entra ID, I believe it's called now. These are examples of off-the-shelf authentication or users' systems. And in the case of messaging here, sorry, I keep going down there because I've got a view here, but this looks like I'm going, yeah. Messaging, you can think of WhatsApp, you can think of Slack. These are messaging products that exist off the shelf. So that gives us a hint that messaging is a generic subdomain and somebody's already done the work to identify the boundary. You can kind of think, well, does this bit of code belong in the messaging service or still in the monolith? Well, does it belong in something like WhatsApp? Would it exist in Slack? Does it make sense for that? So I'll give that a little green tick, but it's where I point out these aren't binary yes, no, it either works or it doesn't, because it's moderator messaging, not messaging as a whole. Maybe some of the features we would consider part of the moderator messaging world, like starting a message from a template, may not be appropriate in WhatsApp. So it's a heuristic. It's an idea that maybe it's indicating that this is a generic-ish subdomain. But that's enough DDD. DDD can be a bit heavy, there's a lot to read, there's a lot to research, there's a lot of buy-in you might need to get from your business. You need more than just engineering involved in. So a much lighter weight option is, if you Google this exact phrase, independent service heuristics, that will bring up a GitHub repository, and it's by the writers of Team Topologies, and it is just 10 questions you can ask about your candidate subdomain, the thing that you're thinking of in your product that may be appropriate to be an independent service. 10 questions, and they're all, again, not binary yes, no. And I won't go through all of them. They all feel like they're on a bit of a Venn diagram, where they all cross over, and they all center around this point, I feel, in the middle, where it's basically, could you run this service, this thing, as an independent product, an independent software as a service product that maybe you could sell to other businesses? Like, could you imagine this candidate that you're thinking of being sold as a little micro business within your business? And I like to I've came up with this totally made up example, but it's great. The authentication users thing from earlier. You know the Google login with Google button? I like to think that, well, they needed to make authentication. They made an auth system, and then somebody at Google went, well, why don't we make that a product in its own right, and other people can use our login with Google button? So they needed to build it anyway, but they've done this. Could you do that with the thing you're thinking of? So to go pick out some of those questions, one of them is about brand. So could you imagine a successful marketing campaign around this thing that you're building? Can you imagine advertising it? Can you imagine, TV adverts or in the bus stop on a billboard, Stack Overflow moderator messaging, and it's got our colors and our fonts, and we can sell it to people that work on community websites. So do you work at Reddit? One day that will come around. But a community website of some sort, maybe you could buy our moderator messaging system. You could think, well, I need to build a moderator messaging system. Those Stack Overflow guys, they know what they're doing. Maybe some of us do, some of them do. You could just buy ours instead of having to build your own. So that's the kind of thing. Could you brand it? Could you do that with your candidate? And I think, yes. I think it sounds a little bit ridiculous, and I've not done the business analysis on whether this would be a good business, a good little micro business. Nobody's come to me and said, hey, we could sell this. So spoilers, we're not building that. So you can put your money away. You can't buy our messaging system. But I don't think it's too ridiculous. There's a couple of questions in there about team resources. So this is basically, is it too big? Could a team in a DevOps world where you build it, you run it, could you run and maintain and support this system as one team? And the writers of team topologies, who were the writers that came up with this list, or some of them, had an opinionated view that a team is a maximum of 9 people. So it's 5 to 9 people. So could 9 people maximum run this system? And in our case, yeah, we were already doing that. We picked candidates that were already areas that we had been working in, that we already had a bit of the knowledge around. So yes, a team can manage messaging in our case. It's not too big. There's some points in there that I've grouped together in ownership, which this means kind of autonomy. Can you make decisions in this area independently? Are you autonomous? Could you give it to a product manager or a product owner who can make decisions about what should happen next in the messaging world without too much influence from the rest of the business or other stakeholders? So to tell you a little bit about how Stack Overflow's organization is structured, we have the public bit that you've probably seen, and then we have a private offering, which if you didn't know, it's called Stack Overflow for Teams. I'm not a salesperson, I don't get commission for this, but it's a private instance of Stack Overflow that you can run, and you can ask your colleagues questions about your own architecture and your own tech radar, your choice of technologies. And that's outside of the public internet, so other people don't see that. And in that world, you don't need messaging. In that world, that's all within your company. You're going to use Slack, you're going to use Microsoft Teams, or you're going to use whatever it is you use to message each other. So we don't have any influence from that side of the business saying, hey, well, there's some requirements for messaging here. Another area we have deals with the API. We have an API, and as far as I'm aware, there is no messaging part of the API, so we're not influenced by that either. So we can talk straight to the end users, straight to the moderators who are using this, do experiments and learn from our users' actual behavior, and make decisions based on that. We're not influenced by other stakeholders. So yes, that gets a big green tick. And finally, I've picked out this one, team independence, which this is kind of the reverse of ownership in my opinion. This is, can you get stuff done without having to depend on other teams? So are you constantly going to be raising help desk tickets? Are you going to be sending a ticket over to the data platform saying we need you to spin up one of these or something like that? Are you independent? Can you get stuff done? And yes, it's a web application. We have been working on this. Maybe you could argue there's some push notification infrastructure, but broadly, we can get this done with our own tooling and we don't have to rely on other teams. So there you go. That's what gave us the opinion that messaging was a good domain to start with, a good candidate. There are plenty more. Go and have a look at the list of the independent service heuristics. Go look into domain-driven design. But that's what we came up with. That's what gave us the idea that, yes, this is a good thing to go with. So the astute amongst you may have noticed the last 3 of those are about the team. So this is not a coincidence. Not just because it was written by the writers of team topologies, but because of this guy, Melvin Conway, if you don't know. Now, usually I try and recite this, but I can see it there. Melvin Conway said, organizations which design systems are constrained to produce designs which are copies of the communication structures of the organization. Pretty good? If you take nothing away from this talk, this guy can recite Conway's law with his eyes closed. This is Conway's law. Conway's law, one of the things I really like about Conway's law is it's a law. Not many things in software get called a law. Things are patterns that you can choose to adopt, or principles, or practices. These are things that you can choose. But Melvin Conway is saying this is a law, like a law of nature, like Newton's third law, or like, Goodhart's law, or something like that. It's something he's observed happens in the real world. You don't have a choice whether to adopt this. And I like it. It makes sense. You can imagine, the example I like is you're testers, your QA engineers in your business. Imagine if you put them all into one Scrum team, just one team full of testers and nowhere else. What inevitably happens, they're talking to each other daily, what happens is they build this lovely test suite, and it's using Gherkin, and it's using all these great test tools, and it doesn't repeat itself. It uses the same test arrangement. There's no duplication. It's a great test suite, and it integrates with your application. But that's a very different architecture to what comes out if you embed one of those QA engineers into each of the teams. And now they're not talking to each other daily. Perhaps they meet up weekly. But daily, their conversations are with the people working in the domains. So now the tests are more coupled to the source, to the domains. They have more domain knowledge, but they have less knowledge about the rest of the test suite. Maybe now we've got some duplication because two engineers have written the same test helpers and they didn't realize. Maybe some tests are written in a different language because, this team's a data thing that uses Python and they write the tests in Python. So that's Conway's law in action. Just simply changing the way the organization is structured, simply changing where the testers lived, change the architecture without some architect coming along and designing what they want the architecture to be. That's Conway's law. You can also apply that to front end, if you put all of the front end people in one thing, and the same with domains. If you have separate domains, people that are involved in messaging, people involved in finance, also works. And I can talk about this forever, but it's not a talk on Conway's law. Let's park that. We have our messaging team now. We have a team that's all the messaging stuff, and when we build this service, Conway's law is going to happen, and we're going to have an architecture that has a nice domain boundary around the messaging service, the messaging domain. And this is what it's going to look like. These are post-its. These are user stories that we've put on a board. We've collaborated together, and we have done a story map. I had never done a story map before, but one of my talented colleagues introduced us to this. I think you're meant to do a story map before you do a project. Obviously, we already have messaging in the monolith, but we can still go through the exercise. We can say, what things does the current monolith do, and do a story map as if we were building from scratch. We've got a bunch of user stories, and they're organized by features and whatnot. So that's the messaging domain. What we don't want to do is build all of this stuff, move all those post-its to the right-hand side and say that's all done, and then turn it on one big switch, one big bang. Best case scenario, we've spent a year on this thing, and best case scenario, nobody notices anything's changed. We just switch it over to the new service. So what we want to do is pick a vertical slice, pick some of these stories, and we want to get them into production first, running in the service, in production, while the rest of the things are still running in the monolith. We're not going to touch the rest of the things. The idea is we don't want to risk breaking them. We'll just do one thing first and get that live. So this is called the strangler fig approach, or strangler fig pattern, or strangler fig something, which is a tree metaphor. I don't know much about trees, but I think this strangler fig strangles the host tree, which I think is metaphorically the monolith that you're strangling. So the verb you use is we're going to strangle these features out. That sounds a bit dark, but we're strangling these features out. So this is the first feature we're going to start with. This is our latest messages feature. It's a little widget. I'm going to draw that for you. Allow me to do some painting. So this is our website. It's got our lovely logo, Stack Overflow, in the top left there. We've got a nav bar on the left. We've got some stuff at the top where we've got the search bar. You've got the user bit where you see your reputation and how many gold badges you've got. This is why they don't let me anywhere near the actual designs. And then you're used to seeing, from landing from a Google search, a question and an answer, or several answers, and maybe a big green tick. But if you were logged in as a moderator, you can navigate yourself over to the mod tools dashboard, now the main body outside of the nav bar is this dashboard for moderators. You know dashboards from your observability tools. They're full of widgets. They're full of what might be going on today. Moderators can see the flags, the recent flags. So when people flag things as offensive or whatnot, they come up. There you go. Flagged for moderator attention on the dashboard. And then there's another widget for the latest messages. This is all the latest messages. Every reply from a user, just ordered by most recent. And you can click in to the messages from here. You say, I want to read that one, and it will take you to the main message view, like the thread. And then there's some other widgets on the dashboard, which for this talk we don't care about. So that's the feature that we're going to move first. That's our strip of post-its. We're going to move just this little view. And now we've got our first programming problem, the first coding problem. Oh, actually, no, we don't. Why did we pick this feature? Sorry, I'll get to that later. Tease. Why this feature? Why not another feature? Why not the main view, for example? Well, a couple of reasons. Again, not a comprehensive list, but we wanted to reduce the risk. So hopefully nothing goes wrong, but if something were to go wrong, we want to reduce the blast radius. This feature here is non-critical, and by that I mean all of this information can be accessed elsewhere. It's just a list of the recent messages, but you can get to the messages from your notifications bar at the top. You can get there from links in your emails. You get an email when you get a message. You can get there, I think, from the user profile as well. There are other ways. So if this feature breaks, it's not the end of the world. It's non-critical. It's a bit inconvenient, but it's not bad. And it's relatively low usage compared to the other things on the site, the other messaging features, because it's on the mod dashboard, only the moderators even get to see this. So a small subset of our users actually get to see this feature. So again, if we were to break things, if we were to break this widget, only a few people are actually going to know about it. So we've reduced the risk. That's one of the reasons we picked this. And secondly, we want to make things easier for us as developers. We want to pick something that's going to be slightly easier to move across. We know that we're the first to build a brand new service. There's going to be infrastructure concerns we need to spin up. There's going to be a 21-point Jira story saying set up foundations that the product manager doesn't care about. There's going to be infrastructure work, and we want to reduce the amount of infrastructure work just for this first feature. So it's read-only. There is no writing. So at some point, there's going to be some data syncing, which I'll get to later. For this, we only need to sync it one way because it's read-only. We're only reading from the database. We're never writing. And secondly, I like this one. It's an entry point in the user journey. So you can start here at the dashboard, and you can click from here into the messages, but there's no navigation back. So there's no page where you, for example, can look at a message and click back to this dashboard, say, take me to page 5 on this dashboard. So it's always the start of a user journey. And again, I get to why that's important later. So that's our MVP. That's our first thing that we want to release. And now we have our first coding problem, our first technical problem to solve here. After we've picked the feature, we've picked the domain, we've picked the feature that we're going to go first, how do we get just that part of the UI to be hosted in a separate service? We want it to be independently deployable, because that's the point of microservices. We want to be able to deploy this new service and see the change to this bit of the UI without having to deploy the rest of the monolith around it, which takes like 20 minutes to build and an hour to deploy or something. We want to make changes just to that one bit of UI. One option we could have done is to just use an iframe, a little HTML iframe. So it, you're cheering, is that what you thought of? You could use an iframe. You could deliver all the black stuff on this page, and then the blue box could just be a frame to another website. That could work, could be good. We decided against that approach. We decided to go for what we ended up calling the embeddable UI component, which is a fancy name for, if you've ever worked in React, Angular, any of these front-end frameworks, you'll know it's components all the way down. You have a button component, and then you can make a search component out of your text box in your search, and then you can make a component out of other components, etc. So we thought, why don't we have a latest message widget component? And then people can embed that widget onto their page just using a front-endy type framework. And One cool thing, so we use Svelte, or Svelter, for our front-end, for our modern front-ends. And one thing I thought was really cool about it is the actual JavaScript is compiled down. So if I were to say, here is a Svelte component you can run on your website, you don't need to be running Svelte as a runtime or anything in the browser. And I don't know if React or Angular work like that, but I know good old jQuery, if you were to download a jQuery plugin, jQuery date picker or something, you have to be running jQuery in order for that to work. But for Svelte, it's just compiled to plain JavaScript, just document.create elements and stuff like that, which I thought was cool. Little tangent. So what does the code look like from the monolith point of view to get that component embedded on the page? In fact, forget the monolith point of view. It's your community website now. You're building something. How can you get this component running on your page? So firstly, you put an empty div. So here I do, div, ID my awesome div, and then a script tag, and it needs to be script type module, which is, I think it's just an ES6 module, I don't know. A module then allows us to do an import here. And now I can go to an external URL and say await import component.js, and that's that compiled Svelte JavaScript file. I've now loaded that into my memory in my browser. Then I've got another line, again, just plain JavaScript, document.getElementById, my awesome div, so find me my empty div. And then it's just some syntax to say, put that I've loaded onto the empty div. We've gone with this new, and then the class name, and then you pass in the target div, and then I've given some example arguments object, but you could have just done a function. There are some syntax that you want to make up to say, put the stuff I've imported into the div. And that's it. That's the script. That's how you get this running on the page. Nice and easy. But what does that look like in terms of the conversation? We're going to do a sequence diagram. You know, a good sequence diagram. We've got three things involved. We've got the browser, we've got the monolith, and the service. So what happens in terms of time? You go to the mod tools dashboard. The browser goes get/dashboard. And that's to the monolith, stackover.com/dashboard. The monolith goes 200, which way am I going? This way. Monolith goes 200 OK. Here is the HTML to render the dashboard. So we can render about this much. But we haven't rendered the stuff from the new service yet. That's, remember, an empty div that was responded in that HTML. And also in that HTML was a script that did the import. So now the browser has to go and import that JS. The browser goes over to the service that way and says to the service, get me that component.js file. And the service goes 200 OK, here is the JS, straight back to the browser, skipping over the monolith. Now, the service, the purple box, could be like a Node.js server-side rendered service that goes and grabs all the messages from the database and returns you some JavaScript that's got all of the data in it. So it can go document, create element, and it's got like the name of the person who sent the last message in there. Or it could have the rendered HTML, and it could give you that. So we could do server-side rendering at this point. But we didn't do that. We thought that might add a bit of complexity. We don't even know how to run Node.js services in our Kubernetes infrastructure and all that. We know .NET. So this response here is actually what we call what I think is called the SPA approach, single page application approach. It's just a static file, static JS file, which contains all of the client-side stuff. So I like to imagine it's the stuff when you download an app that lives on your phone. It's the stuff that runs in the browser. But it's the same every time. It's got no concept of the data that it needs to display. It's just the application. So at this point, we can only render about this much. Like, we can put the word messages. Maybe we can change the color of the border or something like that. But we can't actually put any messages in there because this is just static. But in that static JavaScript is a fetch request or an AJAX request if you're old like me. So now we go get/API/messages to the service. Now, the service can go, yes, 200 OK, here is some JSON, and the JSON contains the data that we then need to display. Now we can render this much. Now we can render everything onto the page. And now we've got front end and back end deployed in that one other service that the monolith doesn't even need to touch. I can make changes to anything in the purple bit, and I can deploy changes to back end and front end without touching the monolith. But if you've ever worked with a distributed system in a front end, you'll know that this isn't going to work. You're looking at that going, nah. And it doesn't work, you're right, because if you've ever moonlighted as a front-end developer, you'll see at this point, you'll get the dreaded cause error, cross-origin request error on that last request, because you're not allowed to just go and talk to another domain like that. So yes, that will happen. And even if we get around that, because you can get around that by changing some things, saying they're all from the same parent domain, even if we get around that, that last request needs to be authenticated. We can't have just anybody able to hit a JSON endpoint and you get all of the messages. There's some private information in there. So we need some security. We need to know who you are, and we need to know if who you are is allowed to do the thing. So this is where we maybe should bring in our user service, our authentication service that we spoke about right at the start. Maybe we should have a service dedicated to giving out bearer tokens to the other services, and the browser can put those tokens on the requests over to the service, and the service knows who you are, and it's great. Yes, we should totally do that. That is probably the way to do it. But we didn't do that because we want to make things simple for ourselves. Remember, we want to simplify the dev. We want to make a first easy version. So what we did was we just stuck a proxy in the monolith, which is just a .NET controller, and the root attribute was just /myawesomeservice /anything with a little star. And that means I go stackoverflow.com /myawesomeservice /whatever I want, and it will forward the whatever I want over to the service. So we hit /myawesomeservice /API /messages, and it will go, yep, to the service, here's that request. But now, when the browser sends that first request, it sends up the session cookie. And the session cookie means we know who you are. And because we are just in a .NET controller, I've got the user object, and I can make all this little contextual information like the user ID and the site ID and roles you've got, whether you're a moderator or not. And I can package that up into a little JWT token, and I can send that in an authorization header over to the service. And now the service knows who I am. The service goes, yes, you are allowed to see this stuff. Here you go, 200 OK, that way, 200 OK, here is some JSON, and we can forward that onto the browser. I need a drink. And this works, by the way. This is a functioning microfrontend with authentication, and it works. But we didn't stop there, because we've got this proxy that says /myawesomeservice /anything else. And we looked at this diagram and went, well, why don't we use that same, we can render that. Why don't we use that same proxy for the component.js call? Why not? Now I'm just going /myawesomeservice /component.js. The proxy was already built to forward that request on. Okay, we're putting some authentication headers that we don't need to do because it's static JS, but it works. And now, notice there are no arrows flowing directly from the browser to the service. We're only talking to the monolith, so I can actually put my service in a private network. It doesn't even need public internet access now. The browser never talks directly to it, which gives us just a little extra sense of security that nobody can actually hit these endpoints directly, even if they tried. So there you go, that's the flow. I want to just focus on this last request, the JSON. We need to get the JSON, the information that's going to be in that UI, coming from the service. So this request needs to give us everything from that UI. The UI looks a little bit better than that, by the way. It's something a bit more like this. It's not 4 lines. We've got a list of messages, and the JSON needs to contain everything that's in there. So firstly, it's an array, so we'll put a square bracket in that response. It's going to be an array of objects, so let's put a little squiggly brace in there. And then those objects need to contain each message. So we've got a name, so let's put a string name in there. We've got an image URL, so we're just going to have a link to get to the profile picture, whatever, .png, .jpeg, .gif, put your favorite image format here. Then we've got the date, so we put that in as a ISO standard date. And then there's an excerpt, there's a truncated version of the message, first 100 characters or something like that. And that's it. Kind of. There's a few IDs in there to make some links, but that's everything that's on the page. And we need to get that returned from our new service as JSON. But all of that data is currently in the monolith. And we can't move it out of the monolith because we're doing this strangler fig. We don't want to touch all the other things. We don't want to introduce some kind of data layer proxy or something like that. So we need to leave the data in the monolith, but we also need it in the service for this response. How do we get it? The instinct, anybody's instinct is, well, we just go and get it from the monolith. We maybe do an API call, or maybe we just grab it straight from the database, right? But let's remember where we are in that sequence diagram. So now we're saying the browser goes to the monolith, get me the messages. And remember, there's a proxy. The proxy goes to the service, okay, get me the messages. Now we're saying that the service needs to go to the monolith. Can you get me that data so that the monolith can go, yeah, 200, okay, here's that data, so that the service can respond back to the monolith. 200, okay, here is that data that you literally just gave me right now, so that it can forward it back on to the monolith. No. We're not going to do that, partly because it's just silly. It's inefficient. Maybe we can add some caching in there, or we can make it lazy loaded so it gets stuff. But then you've got to worry about cache invalidation. Nobody wants to do that. But that's not even why I personally really didn't want to do this. I didn't want to do this because of that. It's a circular dependency or a circular reference where both the monolith and the service need to know that each other exists. They need to be able to call each other. Now, this is quite contentious. Not everybody agrees with me on this. But if I've got time, which I do, I'm going to try and convince you that it's right. And if you disagree with me, please do find me around the conference. Come talk to me at the party tomorrow, and we can discuss this over a beer or two. So, what do I mean by circular reference, by the way? A reference. The monolith has to know where the service is because it's got some configuration that says the service is over here. Here's the URL, that internal network URL that we just spoke about. It's also got knowledge of how the service, what it's expecting, contract knowledge. What is the service expecting? So we've got this JWT key in our config as well. That's not the real one that we use in production. And then the service needs to have a monolith URL as well. That's what I'm saying we don't want, because that's a reference. If the service needs to understand where the monolith is, or it needs to understand what endpoints it can call. It just has to have knowledge of the monolith. That's what I'm saying we don't want. And for a few reasons. So what about your website? What about your community website? You remember, you were going to embed that widget onto your site as well. And if you embedded our widget, and our widget was programmed to call back to our monolith, that wouldn't make any sense, would it? You'd get the wrong data. You'd have all this stuff about Stack Overflow questions. So that doesn't make sense. But I hear you. You're saying, but that's just a thought experiment. We weren't actually going to sell this product to other people. Sorry. I know you really wanted it. We weren't actually going to sell it. So we don't want that thought experiment to impact what our architecture actually is going to look like. And okay, I hear you. We don't. So, but in our case, we do actually have two hosts or several hosts that are trying to use the same service. Because we have several Stack Exchange websites. If you've heard of Superuser or Server Fault, there is a whole Stack Exchange network, and they are basically clones of the Stack Overflow website. They are Q&A sites that focus on different topics. So there's one about chess, there's one about the English language, there's one about music theory, there's one about world building. You can go and play code golf on one of them. They're great. There's 150 to 200 of these websites, and they all talk to the same service to get this data. So what we don't want is the chess moderator to be looking at their mod dashboard, and they look at the last messages, and it's all about programming because it's calling back to the Stack Overflow monolith. They go, what's this? So, but that's because we've chosen to do what's called a multi-tenancy approach, where we have several tenants talking to the same service. We deployed one service. So why couldn't we have just done deploy a service for each one, the same as we've done for the monolith? And yeah, we absolutely could have done that. It complicates the deployment process a bit, and it complicates some other things. It was all a trade-off. We went with the multi-tenancy approach because, as I said, simplify the dev, try and make it easy for us and not solve every problem at once. But that led us to that. And you're still saying, but I don't have 150 websites. that are all going to use the same thing that my candidate is taking out. And yeah, you're saying, I only have one copy of my monolith. Do you? What about your local environments? What about your local monolith that needs to run on your developers' laptops? Are we now saying that, okay, if we take a single tenancy approach, are you going to have to deploy or at least put a local copy of the service on everybody's laptop, and you're going to have to run both of them for any of them to work? You can't run the monolith without the service. You can't run the service without the monolith. Is that what we're saying? You can do that, or you could say, well, actually, I'm going to make it fail gracefully. I'm going to have my monolith just come up with a nice little error in place of the messages if the messages service isn't there. And I hear you. That's a perfectly valid solution. Or you could just run a dev service in the cloud. Okay, now you need internet access to run your local monolith. Okay, fair enough. But it is an easier option, and we were trying to simplify the dev. And if you do it this way, what you don't want is your dev service to call back to the dev monolith from a local call. If you've got this and this is a real battle scar of mine. This has actually happened where in a past life, at a past company, I worked somewhere where we had a Devo 1 and a Devo 2 environment, and we had a third-party integration. We all love them. They've given us a production environment that we can link up to our production environment, and they've given us, thankfully, a sandbox environment. But if you're really lucky, you might get several sandbox environments. We only got the one. So we have the one sandbox environment with Devo 1 and Devo 2, and even staging and local environments. And what genuinely happened was that was configured to call back to Devo 2, so you would do something on Devo 1, you would do something on the other dev environment, it would call the integration would call back to the wrong dev environment, and the dev environment would go, it's trying to give me some helpful contextual information about the wrong thing, I didn't even know this thing happened, and it just blows up. It happened. That's because there's a circular reference between these two integrations. Just sticking on the local monolith, local development front, if you do have this single direction of dependency where the local monolith knows of the local service but not the other way around, you can just forget about the monolith at all when you're working in the service, because it's completely standalone. It doesn't need to have the monolith running. It doesn't need to go and talk to it. What we actually ended up doing was creating this slim host, which does that whole empty dev thing. It's literally just an HTML page that does the empty div thing, it embeds things, and we can run that rather than the monolith that takes 20 minutes to build. So much easier for local development. So anyway, hopefully I've convinced you that this is the direction of dependency you want, and you don't want a circular reference between the monolith and your new service. And if I haven't, do come talk to me. But I do appreciate everything is a trade-off. There are downsides to this approach, and one of them is the data that we were just... Do you remember we were talking about the data on that UI about 10 minutes ago before I went on that rant about circular references? We were talking about how do I get this data from the monolith into the service? And now I've got a direction of dependency where my service doesn't really even know the monolith exists. So my service can't go and pull that data. It needs to be pushed to it. So that data, let's say these two bits here, the name and the profile picture, let's say they're in the users table in the monolith, and then let's say these two bits here, let's say they're in the messages table in the monolith. What we want to do is push that data, that way, over to the service. And then we're going to keep copies of that data in the services database. Not exact copies, because we can have our own representation. Like, we don't need all of the user information. We don't need to know their reputation. We don't need to know how many gold badges they've got. We only actually need to know their name and the profile picture for now. And same with messages. We had an opportunity to remodel it, so we invented this other concept for threads. Doesn't matter. So you can remodel your data, but you need it pushed to the service at some point in time. So there's an endpoint on the service to import the data, which the monolith can use, and your service can use, and a slim host can use if it wants, and test data can go and call this endpoint to import data to the service. And the monolith can hit that firstly manually. We as developers can go, I've just released a thing, and we can tell the monolith, go and sync all of your data, send all of your message data over to the service, go and hit that endpoint. And it will go and hit that endpoint. And we can give it a date range and say, we'll only do the last 2 weeks, because otherwise it will take forever. But that's no good when you've got messages coming in all the time. That means one of the developers is going to have to be employed 24/7 just to hit sync every time somebody sends a new message. So we have an event-driven option So when the data changes, the monolith needs to go and also tell the service, hey, you need to go and update your representation that you've got. So I've pushed the new change. So brand new message comes in, monolith says, here's a new message. But it also needs to do that when the user changes their name, when the user changes their profile picture. It needs to say, hey, this user's got a new profile picture now, go and update your representation of it in your database. So when you serve the view later, it's the correct profile picture. And if you've got an event-driven architecture, this is really, really good. If you've already got these events flying around, you can hook up, you could subscribe to user profile picture changed event, and then just go and send that data over to the service, or username changed event. Great. We didn't have that. So we had to put little HTTP calls every time this stuff changed all over the place. And of course, when you're doing that, networks can fail. Things can go wrong. The service could be down. What we don't want to happen is somebody tries to change their profile picture and it all blows up and can't happen because the messaging service is down. So we want to be resilient. We want to make sure if the service is down, users can still change their profile picture. What we also don't want is a user to change their profile picture or their name or send a new message, and then it try to send it to the service be down, and we allow that to happen anyway, and now our databases are out of sync. That one's still got the old profile picture, and we never went and told it. So what we should do at this point is, I believe, a transactional outbox pattern, where I can say all these messages that I am going to send to the service, I'm going to put in a little outbox table in our database, commit that along with the original change as one atomic operation, and then that can be sent later. That's, I believe, the correct way to do this thing. Yes, we should totally do that. That is the right thing. Other teams can do that later. We didn't do that because we didn't want to make it more complicated. Again, we want to simplify that development for us. So as an alternative, we just have a little schedule that we can configure. So every half an hour, every 10 minutes, whatever we configure it to, the monolith can go and tell the service, here's every message and every username change and every profile picture change from the last 10 minutes, half an hour. And that's great. That means if we miss one of those events for whatever reason, the service was down, we get it 10 minutes later, at least. At most, 10 minutes later. But there's a kind of requirement in there, hidden away, in that we're happy for this data to be out of sync by 10 minutes. We're happy for these two data sources to have different versions of the data for a bit. So we have to talk about eventual consistency. That's what that is. These two bits of data that represent the same thing may not be consistent at a given point in time. They will be eventually, but they're not always consistent. They take time to be consistent. So because this is where the entry point thing comes in. Because we've picked an entry point into the system, we haven't picked something in the middle of the system, we can actually be a bit more lenient with how long it takes this data to be consistent. If we were practicing site reliability engineering and we were setting ourselves good old SLOs, service level objectives, of how fresh this data should be, and we want to say, and we want to base those SLOs on the user experience, how would users tolerate this data being inconsistent? If we had picked a feature to do first, if we had strangled, let's say, the view, so you imagine your WhatsApp thread in front of you, if we'd have picked that view, which is in the middle of a user journey, let's go through that user journey. We'll bring back our post-its from the story map. User composes a new message. They're looking at the screen, they're writing their angry message. They've just been suspended by the moderators. They've spent half an hour wording this angry worded letter, and then they've hit send my message. They hit send. We haven't strangled that feature out yet. So that is in the monolith. Send message goes to the monolith. The monolith puts the new message in the message database, and at this point sends the event, or sends whatever it is, over to the service and says, go and update your version as well. Meanwhile, the browser refreshes, and the user wants to land on the view thread page, which is now in the service. So we go and load that from the services database, and now we have a race. There's a race condition here. Is the event going to beat the browser refresh? Because the event has to get there before the browser refreshes. Otherwise, from the user's point of view, they've just spent 10 minutes wording this angry letter, hit send, and it's disappeared. From a user experience point of view, that is horrible. They don't know that if they refresh the page a few times 10 minutes later, it will appear. They just think they've lost everything, and they get very angry. So But because if this were the feature and we were to set an SLO on that, we'd have to be quite strict with how quick this data needs to sync up. And maybe we need to add some UI features with a little spinner and it's waiting for the data or something like that to give the user, let the user know what's going on. But because we picked something that was at the start of a user journey, the worst possible case is a moderator sends the message, hits send, and then manually navigates themselves back to that dashboard, and they don't see their message there but then they refresh a few times and it is there. It's not the end of the world, that experience. You can forgive it. 99.9% of the time, within 10 minutes is going to be fine. Nobody's going to raise the bug report. So we've given, by picking an early feature in the entry point into the user journey, we've given ourselves, we can make our SLO a bit more lenient. So that's because we've moved this one feature over at this point. Now, eventually, no pun intended, it was intended, but it's not a pun, we will move all of the features across, to do with messaging at least, every part, everything that was on our story map. And then at this point, there is no eventual consistency problem with regards to messages, because every time we read and write messages, we're going to the services database. In fact, at this point, we can totally throw away the messages data from the monolith and only keep the messages data in the service. No consistency problems there. But we still might have the problems, well, we'll have the problems with the user's data. We still might have a journey where, let's say, a user goes to change their profile picture, and it changes their profile picture on the user profile page, and then they manually navigate themselves to a messaging thread, and they see their old profile picture for about 10 minutes. Not the end of the world. They probably don't even have time to raise the bug report. And it's just not a bad user experience. You see your old profile picture for a bit, eventually it syncs up. Maybe one day that user's data gets pulled into its own service. Right? Maybe some other team comes along and decides to make a user service, an authentication service, like we said earlier. It all circles back to that. And maybe in this model, we can pull straight from the user service, so there is no eventual consistency problem. We can depend on the availability of the user service at this point, maybe, because there's no circular reference. I'm talking to another service, another thing. And I don't know, in my head, that makes it a non-circular reference. Maybe. I don't know. And the point is, we don't know what the future, we don't know if another team's going to do this. We can't plan for the future to do this. So I want to just wrap up on a note on the pragmatism of these things and the decisions you have to make. And let's go back to this slide, the multi-tenancy slide. We've got 150 monoliths all talking to the same service. And now we know that each of them, every 10 minutes, are sending data to the service. And in that request, every time they request the import, they're sending across the user IDs. User ID 123 has this name and this profile picture. So we obviously store that user ID in the service. There we go. But user ID number 123 on super user may not be, and probably isn't, the same as user ID 123 on server fault or Stack Overflow. So we also have to store the site ID. Oh, I missed a slide. We also have to store the site ID, which is just a term we used, and we already have this. This is already in the monolith. And I definitely tried to make the argument that the very concept of a site ID means we have a circular reference. Now, suddenly, we're working in this code base, and we have to have knowledge, implicit knowledge of how the monolith is built. And I tried to make this argument, just to make this composite key of the two things. Just the fact that we're using user ID and not account ID or something else. And you have to be pragmatic. Our developers already know these terms. What was I going to do? Make an abstraction and call it tenant ID, and now everybody has to learn this. It gets ridiculous. And maybe, one day, I don't know, these things get moved into other services. We have a user service, we have a site service in future, and maybe that's part of the platform. And maybe, in my head now, it's not a circular reference because they're part of the platform. But I don't know. I can't plan for this future. I don't know what's going to happen. What if your site doesn't even use integer user IDs? Maybe you use GUIDs, right? Am I going to have to make my users now, it has to be a string because it could be email addresses, it could be GUIDs, it could be integers. Of course not. I'm going to use a user ID because all of the known cases that we've got are integers. What if this product is so successful we have millions, billions of customers? Now our multi-tenancy thing's starting to look a bit silly, isn't it? What if we have an integer overflow of site IDs, right? That's now crazy. Obviously, we can't plan for that. That's ridiculous. So we didn't plan for that. All we wanted to do was take one tiny feature, remove a lot of scope. We didn't build an outbox. We didn't build all these other things. And we just got that one feature live into production. And then from there, we can iterate. We can incrementally improve that. That's all I've got on my talk today. Thank you much for coming. I hope you enjoyed how that animated onto the QR code, because that took me forever. If you like this sort of animated style, I do have a little YouTube channel that does 5-minute architectural videos called Drawing Boxes, so please do check them out. I would love some feedback, so do come find me around the conference. Let me know what you think. Do we have time for a few questions now, or should I just wrap up and take them afterwards? Yeah, we've got a couple of minutes. Does anybody have a question? Anything? Nobody want to be the first one? Go on.
So from a podcast from a few years ago, I heard someone from Stack Overflow say that they were really happy with the monolith. And so the question is, did something change in this time, or was this case special that it warranted being in a service?
Yeah, I kind of deliberately missed that bit out and started with the context that we are trying to go in microservice. But that was a huge debate, and to be honest, still is an ongoing debate. Do we improve the monolith from where it is and just stick with it, or do we move to more distributed things? The main thing for me, and I think most people who are proponents of breaking it up, is the build time that it takes. It is so large that to make any change takes 20 minutes to get your CI running, and then you have to go through another 3 instances of that. So even a tiny styling change, just adding a CSS class, takes you less than a minute to do, and it takes you an hour and a half to get it rolled out. So that's mainly what's... but it is still ongoing, honestly, yeah. Any more? No? Cool, well, thank you very much. I'll see you around.